Hi everyone and welcome to next lesson in activity 13. Today we are going to talk about sketching our graphs. Now when we sketch our graphs, we are going to start by finding some of the key features that we already have been finding since the previous lesson. For instance, if we plug in 0 for x, we end up with 0 comma negative 1/2 as the value of our y-intercept. We also can see from this that the degree of the denominator is bigger than the degree of the numerator, so we'd have y equals 0 as a horizontal asymptote. So we can see that plotted in here as well. From there, it's helpful to factor and see, okay, what are our pieces, any holes, any intercepts. This time we notice that the x minus 3 cancels out, and we have a whole value at 3. And if we plug back in and simplify, 1 over 3 minus 2 would be 1 over 1. So aka 3 comma 1 would be the value of our hole. So we see that open circle on our graph. There are no pieces then left other than 1 in the numerator to set equal to 0, so there are not going to be any x-intercepts or real zeros. We will, however, be able to set the denominator equal to 0 and see that we have a vertical asymptote through x equals 2 this time. Now, what's going to happen then is oftentimes what we like to do is plug in some test points to confirm are we above or below the x-axis with our sketch. So for instance, if we plug in 1 for the graph, we would have 1 over negative 1, aka 1 comma negative 1 would be a point. And a lot of times what's going to happen is these are following along then and behavior-wise along our horizontal and then our vertical asymptote. On the other side, if we plug in a test point such as 4, we'd have 1 over 4 minus 2, aka positive 1/2. And we already have that whole value there. So again, we see those values that we can kind of sketch in for our graph. In the next example, again, if we start plugging in some points such as 0, we end up noticing on this one we would have negative 1 over 0. Anytime you divide by 0, that's going to cause an issue. So on this particular example, there is actually not going to be a y-intercept. And then we also notice again that we have a horizontal asymptote at y equals 0 because the degree of the denominator was bigger than the degree of the numerator. Our next piece, if we start factoring to check, we see that we can take out an x squared and that this will cause us to result in another whole at x equals 1. And if we plug that 1 back in to 1 over x squared, 1 over 1 squared is positive 1. So we see that whole at 1 comma 1 this time. We are also going to end up with then a vertical asymptote at x equals 0 based on this information. And since, again, the numerator is only just equal to 1, there's no variables to set equal to 0, there are not going to be any holes to speak of this time, or excuse me, any x-intercepts this time. Okay, now again, if we plug in some test points, if we take 1 over negative 1, for instance, squared, we get positive 1 as an output value. We could also test out, for instance, 1 divided by negative 2 squared. If we plug that in, we get 0.4. So what we see is that our graph on this side is following along, again, those asymptotes and cutting through those test points. We already have that hole at 1 comma 1, so again, if we test out a point like x equals 2 and plug it into our equation, we again see that this is above that x-axis, and this time we have that rational approaching our two asymptotes. Right, the third example we see on the next page, we this time will have a horizontal asymptote through y equals 2 because the degree of the numerator equals the degree of the denominator, and those are going to simplify to be a horizontal asymptote through y equals 2. And then from there, if we plug in and look at the y-intercept this time, we would have 0 comma 9/2. Or maybe you would want to just call that 4.5 as the value of our y-intercept. If we factor on this one, careful on the top, we actually have a difference of 2 squares. So 2 and x squared are 4x squared. 3 squared is 9. So with that difference of 2 squares, we would have 2x minus 3 and 2x plus 3 in the numerator. The denominator, if we factor out to start a GCF, we are actually able to factor this one step further and make this another difference of 2 squares, x plus 1 and x minus 1. So what we notice this time is nothing cancels out, so there are no holes. And the pieces that are in the numerator, the set equal to 0, are x equals 3 halves and x equals negative 3 halves. So 1.5 and negative 1.5 would be zeros on our graph. We also have two vertical asymptotes, one at negative 1 and one at x equals 1. So when we're following along this time, based on those zeros and some test points, we have that 0 here right on the x-axis, so we have to cut through. We have over here this other 0 to cut through, and then notice our y-intercept is up here. So we're going to push away again from that horizontal asymptote and go upwards. There is one then for you to try in example 4. And we will finally finish out with example 5. Okay, again, with the x-intercept this time, if we try to plug in 0 for x, we end up getting a division by 0 issue. So as we talked about earlier, anytime you are dividing by 0, what's really going to happen is it forces our y-intercept to not exist. This time, degree of the denominator is bigger than the degree of the numerator. So y equals 0 would be our horizontal asymptote. And then factor to find our remaining pieces, we'd have x squared plus 2x minus 3, which, again, we could kind of factor a little bit further to be x plus 3 and x minus 1 as those factors. Now this time we are going to have a hole that cancels out at 0. And if we plug in 0 for x, we would have 4 divided by, down below we'd have our first set of parentheses. If we plug in 0, we would have 0 plus 3 and 0 minus 1. So that we see an output value of negative 1.3 as that, so negative 4/3 if we look at that as a fraction. So hole right here on the y-intercept, which also makes sense why then we didn't have a y-intercept, because it was a hole. And then we have nothing other than 4 then left to set equal to 0 in the numerator. And we do, however, have two vertical asymptotes, one at x equals negative 3, one at x equals positive 1. So we see those passing through. Now this one's going to be a really nice example to use some test points in. And again, whether you plug it into the original or you plug it into the factored form, on this one, if we check out some test points, for instance, let's say negative 4 value over here. Even if I plug it into the original, I'd have 4 times negative 4, and then all of that divided by negative 4 squared, cubed, plus 2 times negative 4 squared, and then minus 3 times negative 4, I end up with a positive value of 0.8 when I plug that in. So that means my graph is actually going to be above the x-axis. Over here, we already have this whole point here, but let's say we want to test out another point. Let's say negative 1 or negative 2, for instance, would be a good one. If we plug in negative 1 as our value for x on this one, what we're going to see is that we get a negative output of negative 1. So again, we're kind of confirming that this stays below the x-axis. And then finally, if we test a point, let's say positive 4 on this one, so that we see a number bigger Then our y-intercept, our vertical asymptote at x equals 1, this time we see a value of positive 0.19. So again, we see this very tiny point, but very still positive point. So we could shade up above or draw in our line. All right, thanks everyone for watching. We will work more with our sketches in class.